Good. The talk today is about metadata in action. So what it means is more or less the project results of the NFDI for bioimaging project at the current stage, and the I4D Bio project that's end last year or at the beginning this year. And I'm not sure, maybe you heard something double or twice because, yeah, I'm not aware of that, what the speaker before me told you. So, yeah, sorry for that. Um, Metadata in action, yes. So as a short intro, so the level of data management, do you have different levels of data management? On an individual stage, you have other requirements as on project stage or institutional, and you have collaboration. You surely comes to requirements on a national level or on an international level. And this is where these different working groups and project drops in. So the RDM4mic meeting is mainly interesting on a project level data management and on an institutional level, and as well as the I4D Bureau project as a working unit for the RDM4mic group to implement the needs of the RDM4mic group. And if you have then the collaboration on a national or international level, you have other requirements on the data management, on the data formats, as well on the metadata formats. And that is what is covered by the NFDI for bioimaging project. So you've tried to define national and international standards to fulfill all the requirements. But first, I want to talk about the I4D Bio project. So the core mission, as I said, is that implement the needs of the RDM4mic groups. That means implement tools and give support and training with the focus on mirror and light microscopy. As an outcome, we have this overview or this guide for structuring data and metadata for bioimaging, and that covers the conceptual and as well the technical solutions in the context of linked data or web data, so to say. And we provide workshop and training material. Please have a look at our Zenodo community where you find a lot of the material. The training material is very useful for the project and institutional level to teach your users and how you can do the data management together with Omero, what you have pay attention on and so on. We also publish a practical guide for research data management in core facilities that include tables of common issues and give a hint how you can solve these issues. And we cover here each stage of the, so to say, life cycle in an image core facility. And yeah, have a look on it. And what else? So I told you that we also try to implement tools or are the working unit for the needs of implement tools. So we took over the maintenance of Omero Autotech and Omero Tech Search. Then there was some developments on the Omero clients and especially on the Omero web client. We develop a linkage toolbox that include tools where you can connect or send metadata from Omero to your ELN and interlink this both directly without the sync. Also, for teaching support, so to say, we develop Tom developed a web client that includes a gamification to learn how to use tags and key values in Omero. This is done like a treasure hunt. For the Trends of Microscopy conference, we provide a concept and an infrastructure for data management, and teach the user how you deal with the metadata, with the different metadata from different setups. And the results are published as a Omero server with the annotated data from the Trends of Microscopy. And we also provide a knowledge hub at our website. That's what the RDM4mic team has done. And the NFDI for bioimaging project, as I said, it's more the mission to cover the data management on a national and international level. So that means for German researchers and across disciplines, interlinked domain and have this link to the international framework. So I want to talk about mainly on things we have done in the task area 1. This is about image metadata and data formats and standardization. The main points we cover here is that we want to create a fair digital object. We want to have at the end a cloud-ready open file format, and we want to have metadata standards and tools. In very brief, the digital object for bioimaging, what does it mean? That means we have this fair digital objects. It's a kind of package, and we want to make this imaging data now compatible with such a FDO package, and we want to ensure with that the data is open web accessible, and we can easily share all the data together. The cloud-ready open file format, yes, another new file format, but it's worth. The world is changing, so to say. We have this main work in the web, so to say, and we have to adapt the file formats for that. So what it means in brief, up to now we have or a TIFF file, for example, is a monolithic file format, so to say. That means if I'm working on a network, I have to download the whole file if I want to only visualize a part of it. And this cloud-ready open file format means that the data themselves is chunkable, and I don't have to download the full file. I only download the package I'm interested on, or the part of the file I'm interested on. That has pros and cons. I listed some of that here. But one benefit, and this is very important, is that I can access the image without a download. And this is a nice example from made by Kristen Schmidt. You can download, or you can loading and viewing a data set over 100 gigabyte on your smartphone. It's not important to have this big hardware behind that. Of course, you need the network behind that, but not the hardware themselves. And it's very easy then to view data. And we have a standard access, and the benefit of that is we can now open a file that's represented by an URL in different web-based viewers. We are not agreeing of one software and one viewer. We are able to use different one. You can select the one you like, so to say. Metadata standards and tools. The goal of this is that we have at the end a web of metadata. That means that we improve the data discovery, we increase the data reuse at the end, we enhance the interoperability, and we ensure that the data is machine readable. But this is not that easy because we have very diversity image modalities in microscopy. We have a high diversity in proprietary file formats that we have to cover. And we have a diversity in standards. So there are lots of recommendation and standards which metadata is necessary for what and for whom. So this is also hard to cover because you're interested on the one part of the metadata and your colleague is interested at totally another part, and you cannot cover all and see all coming, so to say. At the moment, the standard, so to say, for storing the metadata is the OME data model. That's serialized or is materialized in the OME XML file. But that cannot represent all vendor-specific informations, and it's not really idle to integrate other data. So we decided to go to within a modular framework so that we have or we can store parts of metadata in boxes, so to say, and we can interlink that together. But this is very critical if we does not agree on a unified format for that, for this box, so to say. So that means it is very easy to represent metadata or to create a representation, but it is hard to building a common one for all. Remember, the goal was web of metadata, and this is the steps we take to get that. First, we convert the Homero data model, the XSD representation, to a LinkML representation. And this is necessary that we have an URL for each class of prediction so that we can use later on. Then we translate the Homero-specific metadata into a research description framework. We use the tool Homero RDF for that. And that enrich the data with semantically context and integrates the URLs for each entity, so to say. And that simplifies at the end the integration with other data coming from other domains. Sorry. And then we map the metadata to a virtual knowledge graph. We use this tool Homero onto mapping for that, so that now Homero or this virtual knowledge graph act like a Sparkle endpoint, and we can now fetch easily data via a Sparkle query. And we can use SQL as well for that, but we can now do that for distributed data silos, so to say, and bring all the information easily together. And another steps we take is how we package now all the things together, the data, the new formats, and the metadata. And we define a minimal layer, so to say, that includes the technical information and as well as sample information. And we use the row crate format for that. So we link the new file format or the new raw data represent via a URL in this row crate. And we also link this metadata in that. And this is a short example how it looks like. It is, human readable, but as well machine readable. And we easily can that represent as a graph to get a better overview and to integrate and interlink our informations. Yeah, if you're interested in read more, all the stuff, you are invited to have a look at our worksheets or guides, so to say, of the different topics linked here. And with that, I come to an end and thank all of my colleagues from the NFDI for bioimaging and from the R3D Bio project. Yeah, and happy to get your questions.
Okay, Susanne, can you hear me?
Yes, I can hear you.
I maybe have one. So to create this linked data format or the digital object, the row crate, whatever. So you need the metadata and the file, the experimental metadata and the technical metadata, and then you're converting it directly from the files inside of Omero, or where you're getting the metadata from.
You can, it's depends on what your question is. So if you want to query information, then you're mapping the Omero database to this virtual graph, and then you can query inside this graph and connect your information with other virtual graphs or material graphs. That's on the one hand possible, or you want to share or publish your things, then you package all the things together in such a FDO and deposit this FDO somewhere. It's a small information. It's like a README file, right? You find all the necessary information. Where's the URL to my raw data? Where's the URL to my metadata? This is in principle what an FDO can be or is. That brings the information together, but the raw data themselves can lay on a different storage as the metadata, or you interconnect the raw data in Omero with the experimental metadata in ELN, for example. So it's also possible with that.
And this Omero on top is a tool which are creating the linked metadata, or how do I, if I need it local?
This makes more or less takes this relational database from Omero and transfer it to a virtual triple store. You don't have to really implement a triple store, but it makes it on more or less on the fly.
Thanks a lot.